Hello everyone. So this is going to be the video for this week. It's only going to be one video because the teachers are going back in to get school ready for some children to steadily start coming back. So we're not going to have as much time to make videos because we'll be teaching. Also, if you've got any issues, please do email, but it will take us a bit longer to get back via email due to me being in school, but we'll do our best. So we're going to carry on with algebra this week. That's what you did the week before half term, nothing too tricky. And I picked the first lesson that you'll be starting on, so lesson 6 to do the video for, because I think that sets you up for the rest of the week. So first off is our starter, to get ourselves warmed up. So you're going to choose which ones to do mentally, which ones to do a written method for, and then we'll go through the answers. So get it paused in a second, and then unpause, and we'll go through answers. Get it paused now. And hopefully you're back, so let's start going through those answers. The first one, 3/8 of 64. Okay, that was a mental one because we say how many 8s go into 64, or 64 divided by 8 quickly, and it is 8. And then we look at the numerator, which is 3. We do 8 times 3 to give us 24. Second one was a written method, 10,000 numbers, no real relationship between. We could look at the hundreds column, 4 and a 7. We know we're going to be carrying columns and things, so let's do it as a written formal method. 8,701. Next one, definitely mental. As you know, the 98 is going to stay the same. The only thing that's going to change is the hundreds number. 8 take 7 is 1, 198. This one was mental as well, so 765 take 80. Okay, lots of ways to do it. You can take 65, take 15. Gives you 685. Last one, 27 times 73. 2 tens numbers. Look quite tricky to do. You're going to do it as a formal multiplication for 1,971. Right, let us move on again. So for today, we're going to write and evaluate algebraic expressions. So we're going to write them. And evaluate means sort of think about, is there more than one? Is it right? How do we know it's correct? So here's our number crunching machine. What could the rule be? That word could, not what is the rule, what could the rule be? So we've got 12 and 4. Let's have a little think now. What could it be? How do we get from 12 to 4? What ways can you think of? How many ways can you think of? Let's have a think about that one. Okay, so we could do, oh, I don't know, if we halved it, no, it'd be 6. We took away 5, no, it doesn't work. So let's have a look at the ways we could do it. So first way, this chap thinks it's x take 8. Okay, so the algebraic expression would be x take 8. When x is 12, which is what the input was, so if you flip that, that's what the input is. So when x is 12, let's put in x take 8, so 12 take 8 gives us 4. So if we flip back here, 12 take 8 gives us 4. So that works. But is that the only way? Probably yes, no. But that is a way that works. So x could be, the algebraic expression could be x take 8. This girl here thinks it's a third x, a third times x, remember? Because so a third times x, so when x is 12, a third x means a third times 12. Now when we times by a third, we want to split that number into a third. What is a third of that number? Okay, so a quick way to do that, can divide it by 3. So 12 divided by 3 is 4, times it by 1 for 4. Or we can just count up 3 times, so 4, 8, 12, and then you know we've got one of them. So what goes 3 times 12 if you want to? Or we can say 12 divided by 3 equals 4, and then multiply by the 1. Whatever way you want to do it, but that works as well. So a third x works as well. There's a third expression here. She thinks it's x divided by 3. So when x is 12, so x divided by 3, 12 divided by 3, 12 divided by 3, hopefully we can do that quickly in our heads, is 4. Okay, but we can also write x divided by 3 as x over 3. But that works. So that's 3 expressions. We've evaluated and thought about all of them, and they all work. There's more than one answer. That's all you're going to be doing today, is making things that work. So let's have a look at these ones. So write an algebraic expression in terms of y to describe the rule used by each machine. So let's look at machine A. 8 becomes 2, 20 becomes 5, 12 becomes 3. Y will then output what we're going to write an algebraic expression. So if we look at the first one, take away 6. 8 take 6 is 2. Let's see if it works here. 20 take 6 is not 5. 12 take 6 is not 3, so it can't be that. How else do we get there? Well, I can know that 2 and 8 are in the same times table. So I'm going to do 8 divided by 4 will give me 2. 20 divided by 4 will give me 5. And 12 divided by 4 will give me 3. So I've pretty much got it there, which means that y, so if this was 12 divided by 4, y divided by 4 should give me my answer here. Remember, when we say divided, we can write y over 4. Okay, so y over 4. B, so 8 becomes 2, 20 becomes 14, 12 becomes 6, y becomes something, the expression. So we've got 8 and 2 again, so divide by 4. So 8 divided by 4 is 2, 20 divided by 4 is not 14. So we know it can be the same to get from 8 to take 6, 20 to 14, does it take 6 work? Yes. 12 take 6 gives you 6, so it's take away 6. So we're going to have our initial input y take away 6. Easy enough. Oh, wonderful. Look at that little arrow there. I'll put an extra number. Let's delete that. So complete each table. So the rule is m over 5, which we know means m divided by 5. So if we put 10 in, 10 divided by 5 is 2. Now we're going to have to use the opposite here, because if we get 10 out, once it's been divided by 5, use the inverse. Inverse of division is multiplication. So let's do 10 times 5 to get the initial number. So 10 times 5 is 50. 3 divided by 5. Now we can just write 3 over 5 and leave it like that. Or if you've worked it out, it's 0.6. And then we need to use the inverse again. So if 3 would be here, and it's been divided by 5, so do the inverse to find the original number. 3 times 5 is 15. Easy enough. And then B, n take 5. So if n is 10, take 5 is 5. Now we're going to use the inverse again because we get 10 out and we've taken 5. So to get the original number, we need to do the inverse of take, which is add. So 10 add 5 is 15. And then here we know we're going to get 0 out. So we need to do the inverse again. So 0 instead of take 5, do the inverse. 0 add 5 is 5. Okay, so you just need to think, do I need to use the inverse? Can I make a rule that fits for all of them? Okay, now that is you for today. So today you're going to complete page 51, worksheet 6. Give it your best go. And then through the week, worksheets 7, 8, 9, and 10. They're all okay. We move on to looking at formulas. Okay, so formulas link to our algebraic expressions, so they work for certain numbers, certain cases. Tomorrow is writing algebraic expressions again. And then our last one is solving equations. So that instead of an expression, it means it equals something. Equation means it equals. We've looked at all this before, so it shouldn't be anything too taxing. Anything that is tricky, give it your best go. Have a really good go. If it's too tricky and you've had a go, move on and do some of your English, some of your reading. Okay, it's not the end of the world. If you need to email, that's fine, but don't feel you need to. Just do what you can. Okay, and there'll be another video up next week, and we're available to help if you need us. See you later.